Hello, this is Anthony with Copley Controls, and today we will be showing how to use TwinCAT and making moves with a structured text program in CSP mode. First thing you want to do is make sure your drivers is in good condition, good health. So we're connected over serial to a BEL. It has 520 EtherCAT firmware inside of it. It's enabled in can open over EtherCAT mode. It's not actually it's not enabled over EtherCAT, but it is ready to be enabled. There are no faults. So let's go ahead and start up TwinCAT. So I'll create a new XAE project. Okay. IO. Scan. Great, the drive was found on my Ethernet adapter. And you can append a linked axis if you want to. That's used for easy control. So if you don't want to do structured text and you just want to use a GUI, you can go ahead and do that. So like if I click this button here, it activates the configuration. It sets it up in run mode. And then go ahead and go on this axis and can actually enable the drive and start making moves. And I can see that here. I'm also enabled and I'm able to jog the motor. So see all these green lights, that means that we're actually enabled by the EtherCAT main device, TwinCAT, and we're pushing current. So I can jog it slow or fast. If I get any kind of issue, like if I try to, so these plus plus and minus minus, that's if you want to go really fast or really slow, and you might get, oh, a following error happened. So before you can go back to using those buttons, you have to clear the error. So here's your error code. If you want to clear it, you just hit this R button, reset, the error goes away. You can do a continual jog with this button here. Now we're jogging continuously in the positive direction, going about 130 RPM. So I can hit this R again. Let me go ahead and stop this controller. This is nice for testing, but I actually want to write a program that'll do similar kind of back and forth moves. So I'm going to take it out of run mode. I'm going to put it back into config mode, and we're going to get rid of this NC task. So let me remove it. And then click this button here. Great. Now we have, now we're ready to go. So I'm going to create a structured text PLC project. So go ahead and create a standard one. I'll just call it CSP mode move. Okay, great. Created the project here. So now we have some different folders. So by default, we get this main program here, and it's going to be running as the PLC task. And we can create some variables here first that we can map to our PDOs. So we get some PDO variables down here that are being updated all the time, back and forth from TwinCAT and the drive, and then we're going to read those and write to them using global variables in here. So I'll add a global variable list, And I'll just I have it right here, my global variable list that I want to use. So the first global variables here, these are the TPDOs. So all of these inputs, the cyclic inputs, we're going to map to those. Anything, so if you see I, that means that it can be linked to the inputs, and then a Q is can be linked to an output here. So technically, so an input meaning like a TPDO, and an output would be an RPDO. And then over here, I actually have just a variable that I'll be using in my my project. So you know, you can have multiple PLC tasks running, and if you want some kind of global variables that are seen between all those different tasks, you can create them here, and you don't have to link them to any process data, but they're very handy. Another thing with structured text, you can't do any kind of bit shifting or bit operations like ANDing or ORing bits. So you actually have to create data types, or you have to create structures. So then you can set those bits manually and then update them that way. So it's a little workaround, but I'll show you how to do that right now. So I'm going to go ahead and create a DUT. So it's going to be a structure, and I'll call it the control word struct. I'll create another one for the status word. Okay, and I'll create another one for the event status. So the event status word is actually just a Copley specific object. You might not have heard of it, but it has a lot more bits inside of it. It's got all the different events that can happen. It's helpful for debugging. But the control word and the status word are DS402 protocol. Very typical. Any kind of DS402 device has those, and we'll be using those in our program. So we've created global variables. We've created these structs. Let me fill these structs in here. So here we're going to define all the different kind of bits that are in this parameter. So we can reference them. It's the control word. Here's the status word. Okay. And then finally, here's the event status word. Great. Save that. Okay, now those errors go away over here because they're defined, the structs. And now I'll create some, so here we have the main program, but I'm going to create some functions that I'm going to use in this program. So you say POU, and I'll create a function, give it an integer return type, structured text. We'll call it clear false. Very handy. And then we'll call another one enable drive. Okay, great. And then I have some program here. Here's for clearing the faults. When you clear the faults, you just toggle bit 7 of the control word. So we'll set it there. And then to enable the drive, you set the control word to 15. Okay. Now go to my main program. Okay, so at the top here we have our variable declarations. I have created a few variables here, target position 1 and 2. I have a sequence selection, that's how we know where we are in the program. So this main program it'll be called, a lot, very often by the computer, by the operating system. It's a task running, and so this will be running all the time, looping. So what I do first is on startup, we'll calculate some target positions, and then if we're not enabled, we will go ahead and try to debug that. So if there are any faults, then we'll clear them, return. If we are still not enabled, then we'll go here, and it could be that you're getting a following error continuously. So you should set wherever your target position is to where you currently are, so you don't get that following error anymore. And then enable the drive, and then return. And then that should fix any issues. You should be enabled and holding position there after this. After that, you can go ahead and begin making a move. We're going to be making a move to, we're actually going to be making a move 3,000 counts in the positive direction from where we currently are. And then the next move will be making a move back to the original position, minus 3,000 counts, because we did this here. So we'll be going back and forth between these two target positions. So we're all set, ready to go. We're in config mode. We save, we build. Okay, we need the async master at least one variable linked to a task variable. So we're going to go ahead and go down here. We're going to link these variables. So the status word PDO will be being linked to this global variable being used in our program. And when we do that, we can see this little arrow here. We're going to do this for all these. Okay, and then I think I need another PDO for the event status word. So I'm going to go ahead and go click on this, my drive. I'm going to go to the process data, and the event status will be a TPDO. So I'll go in here, and I'll get the event status. Oh, here it is. Okay. Okay, great. Let me do this. Okay. Oh, and then let me see, inputs. Okay, I have to click on it. There we go. All right, now the event status word, and I'll link that up with this global variable. Great. Now I'm all set for actually running this. Let me save, build, and then activate the configuration. So here I'm going to log in I'm going to download and then start. So I'm moving back and forth about 6,000 counts. Oh, exactly 6,000 counts back and forth between target position 1 and 2. So yeah, this is how you'd make a move to 2 different positions in CSP mode via a programmed text PLC. A structured text PLC program. So yeah, I hope this was helpful, and reach out with any questions.